Okay, so the broadcast is starting.
Okay, so we should go to start.
We have still 2 minutes, right, to go. Okay, can we start? Can we? All right. Good afternoon, everyone. It's my great pleasure to welcome you to today's webinar dedicated to an introduction to the Biomonitor Project. I'm Dusan Drabik. I'm an associate professor of agricultural economics at Wageningen University, and I have the great pleasure of moderating today's webinar here. Just a few words how this will be organized. So after each presentation, there will be a room for 1 or 2 questions, for immediate questions. And of course, at the end, we will gather further questions and into a larger discussion. And we would like to ask you to use your, to put your questions into the chat such that we can follow it and then pick up them in the end. I have the pleasure of introducing 3 wonderful speakers we have here today. The first one is Justus Wesseler. Professor Justus Wesseler is the chair of agricultural economics and the rural policy group at Wageningen University in the Netherlands. His research work is on the economics of biotechnology, value chain economics, regulatory economics, and the bioeconomy. He is the president-elect of the International Consortium of Applied Bioeconomy Research, otherwise known as ICABR Consortium, and is the coordinator of the EU-funded project Biomonitor, which focuses on measuring and monitoring the bioeconomy. His research work on the economics of the bioeconomy has been published in more than 100 contributions to peer-reviewed journals and books. Our next speaker will be Max Kardunk. Max is a PhD candidate in the Agricultural Economics and Rural Policy group, also at Wageningen University. He's working under the supervision of Professor Wesseler, and his research focuses on measuring and monitoring the bioeconomy. The research employs quantitative and qualitative methods to assess the economic, social, and environmental impacts of transitioning from a fossil-based to a bio-based economy. And last but not least, we have George Philippidis here with us. George has worked on topics such as agricultural policy, international trade, climate change, technological change, and more recently, the bioeconomy. He has considerable expertise in both national and international projects and has published over 50 peer-reviewed journal publications. His principal expertise is in the use of multi-sector computable general equilibrium models. He has significant experience with the magnet model and is the main developer of other models used both in the UK and Spain. George is an active member of the GTEP community and the GTEP Research Fellow. He has worked as a senior researcher at the European Commission and continues to collaborate with the JRC. So now that we know the people who will be talking to us today, let's talk a little bit about how this webinar will be structured. So it will have two basic parts. In the first part, we will have three presentations. Justus will introduce us to the Biomonitor project, then Max will present the framework for assessing the development of a circular bioeconomy, and then again Justus will take over and will provide more information about input-output approach which can be used to measure the bioeconomy. And this session will be concluded by George, who is going to talk about some practicalities of using simulation models in the bioeconomy. And in the second part, of course, we will have our general discussion, and there will be space for questions. With this, I would like to hand over to Justus to introduce us to the Biomonitor project. Justus?
Yes, thank you, Dusan. And now let me share my screen. And can you see my screen? Can I just get a feedback if my screen is visible? Okay, good, because I myself cannot see if you can see it. So it's a great pleasure to introduce the Biomonitor project to all of you. My name is Justus Wessler, as Dusan Drabik has already mentioned, and I'm the coordinator of the Biomonitor project. And what we do within the Biomonitor project is, and now I have to move this down here because I can't see my own slides, is to address the objectives of the European Union, which have been summarized in the bioeconomy strategy, where explicitly has been mentioned that the contribution of the bioeconomy should be to contribute to the prosperity of the citizens in the European Union, but also within the global economy. And one of the big challenges, of course, is how this can be implemented. So what are the indicators, what are the measures, what are objectives, policy strategies that could achieve this. Now, within our project, which received funding from the European Union in 2018 and will run until the end of next year, we have the objective to implement an effective framework that is able to monitor the development of the bioeconomy and contributes to the aforementioned strategies of the European Commission and the European Union. And for achieving this, we want to develop a data set and a data collection strategy that allows to provide important information that then later can be used for modeling the developments of the bioeconomy. And while doing these two activities, engaging stakeholders along the way, so that we, in a continuous exchange with those stakeholders, adjust and also refine our approaches to ensure that we take those views also on board. And finally, we of course have to communicate the results and progress that we are achieving within our project. And the webinar that we have today is one of these activities. Now, this slide here shows you the conceptual framework, which basically summarizes the important issues that are related to monitoring the bioeconomy. We have on one hand an important drivers that have an effect on the bioeconomy that include, for example, policies, the overall economic development, how consumers respond to specific policies, to specific products being generated. Then we have demographic changes that also affect demand. And then we have, of course, innovation and technological changes that also make a contribution. We have to consider what is going on in our environment, and in particular, climate change plays a very important role. We have policy strategies that also affect developments, and as I have mentioned already, the bioeconomy strategy is one important aspect in that context. We have resources where the bioeconomy depends on, like land, water, but also labor. We have issues that are related to using byproducts that are generated within our economy and how they can be used. And they all affect the overall development. And they are also, of course, linked to some of the larger challenges like food security, natural resource management, natural resource dependency, climate change, and economic competitiveness and employment, job creation, which are also extremely relevant. Now, in our conceptual framework, we embed the bioeconomy within the larger field of what we would call the green economy. And within our project, we in particular look at what we would call the bio-based economy. That is a part of the bioeconomy that uses biological resources not for food but for other purposes. For example, producing biofuels, producing succinic acids, producing other valuable biopolymers that we can use in our economy, that processes, for example, timber or wood into useful products such as chairs, cabins, houses, and more. Now, to get this implemented, we orient within our project ourselves along the lines of the objectives within the EU bioeconomy strategy. And we try on the first step to identify indicators that are linked to those strategies. And you can see here the allocation of indicators according to the bioeconomy strategy. Now, if you would love to know more about the overall objectives of our project, who are the people being involved and more, you can look at our website at biomonitor.eu to find further information. Also, you can receive there further insights about the progress that we have made so far. We also have an introductory video that you can watch either on YouTube, but you can also find the link to the video on our website. And with this, I like to finish my introduction to the bioeconomy Biomonitor project, and I would love to hand over to Max Kadung, who will now enlighten you a little bit more about what we have done so far with respect to looking into indicators linked to the EU bioeconomy strategy. So thank you very much for the time being, for your attention.
Yeah, thanks, Justus, for the introduction. Just gonna share my screen on my presentation. Okay. So as Dusan already mentioned, yeah, the title of my presentation is Framework for Assessing the Development of a Circular Bioeconomy, which is a framework that we worked on during the Biomonitor Project. And so first of all, before I start my presentation, there were some questions that we were showing to the audience to get some overview over your background. Do we have the results for the first question?
Not yet.
We don't have the results yet. Okay, then maybe we can share that later. And as you can see, already the second question that we would like to know is where you're from. So we have different options where you're from. We expect most people to be from Europe, but which part of Europe, or also if you're not from Europe, you can choose other. Then I guess I'm gonna proceed with my presentation now. So Justus already introduced a bit that bioeconomy is a very I have a bit of a problem. Okay, bioeconomy is a very broad concept that includes a lot of different sectors. Yeah, basically all sectors and systems that rely on biological resources. And if you talk about circular bioeconomy, then that means that you should apply the principles of a circular economy as much as possible, which means also maintaining the value of products, materials, and resources as long as possible, and to minimize waste generation. The circular bioeconomy can be an effective approach to tackle problems such as climate change, the unsustainable use of natural resources, and the growing income inequality between rural and urban areas. But to achieve that, the transition needs to policy actions that promote the sustainable use of natural resources, as for example, soil. And it also needs high expenditure on research for new technologies, as well as education for new and restructured jobs. We need to measure the progress of the bioeconomy because in order to manage this transition in a sustainable way, we need to know what's going on and what impact it has on the economy, the environment, and society. And many indicators can accomplish this goal. There have been a lot already proposed, like measuring, for example, the share of organic farming areas, or determining the rate of bio-waste recycling. And also a lot of indicators have already been established for other policy areas. For example, the United Nations Sustainable Development Goals have 331 indicators that measure the progress. And also for the bioeconomy, a study by Lee et al. Already proposed 161 indicators. And also in our own Biomonitor project, we have already proposed 84 different indicators. So this wide range of indicators also means that it's not easy for policymakers to track the progress of all of them and consider them in their decisions. So with our framework, we try to make it easier for decision makers to see the big picture of the whole development, while also informing about the small nuances. So we try to find patterns in the evolution of the circular bioeconomy using any number of indicators, and also applying a technique that is called Markov transition matrices to look at the dynamics within the bioeconomy. And that we use to compare the evolution in different EU member states. You can see the list of countries here. and it's also possible, of course, to add more countries to this. And we look at the time period 2006 to 2016, which is mostly due to the available data. So yeah, the data is of course often a problem. So we needed a very consistent and long data set. So in the end, we took time series data from the Eurostat's indicator set to measure the progress towards the Sustainable Development Goals, as well as the monitoring framework on the circular bioeconomy. Combining these two, we in the end had 41 bioeconomy related and circular economy indicators. And before applying our framework, we needed to check the indicators for consistency in the interpretation. As you can see in this list of some of the indicators that we used, some of them should be as high as possible, for example, the value added. Some of them should be as low as possible, as for example, ammonia emissions from agriculture. And some of them should be in balance, as for example, the nutrient balance on agricultural land. So after ensuring the consistency of the interpretation of our indicators, we basically, broadly speaking, had 4 more steps in our framework. First, we used z-scores to normalize the indicators and removing all units and magnitudes. Then we used least square estimates for the slope for each indicator to rank them according to their development over time. The third step, we use these Markov transition matrices to analyze of the interdistribution of indicators over time. And the fourth step, we use a mobility matrix to easily compare the extent of this indicator movement between countries. So coming to our results, first, and take a look at this big picture I was talking about. So in this graph, you can see how the whole bioeconomy is developing over time. You can see the distribution of all the indicators going from the earliest year on the top to the most recent year in the bottom, and going from negative z-scores to positive z-scores on the right. So you can see that the distribution with each year is shifting to the right, which means that the bioeconomy in general is progressing. They're looking at box plots. You can see a similar picture. So the bold line in the middle means that is a median, which is constantly increasing over time. And the little box represents the interquartile range, which is a bit decreasing within the middle of the period and is higher at the end and the beginning of the period. And now, after having a look at the whole picture, now we can also look at in more nuances, comparing all the different indicators. So we did, for each country, we ranked the best and the worst indicators. Now I'm only going to give a few examples of some countries. For example, in Germany, you can see that 2 indicators representing the share of renewable energy in the electricity sector and in all sectors combined are the top 2 indicators. While, yeah, this could be one consequence of that bioenergy was promoted a lot in Germany. So at the same time, but you have the ammonia emissions, which are 2 of the worst indicators, which again could be a negative side effect of promoting a lot of bioenergy. And in Finland, you can see that also the share of renewable energy is among the top indicators, but the research and development, 3 of them are at the top, at the worst indicators, which is of course a bit alarming, as a lot of research and development is needed to progress the bioeconomy. And then we look at 2 more examples that I picked out. In Slovakia, you can see that one of the top indicators is the greenhouse gas emissions, which means in our case that they're going down, of course, while at the same time the gross nutrient balance in agricultural land is regressing, which also shows that you can have at the same time an environmental indicator being one of the top indicators, while at the same time another environmental indicator is one of the worst. So if you would just aggregate all the environmental indicators, you would lose out on this information. And similar in Latvia, you also have ammonia emissions among the worst indicators, while the surface of marine sites is one of the top indicators. And then next, we looked at interdistribution dynamics using the Markov transition matrices, which is on the one hand on the short term from 1 year to another, and then also over the whole period in the long term. So what you get in the end is a matrix, as you can see on the right. I'm not gonna go too deep into that, but giving two examples, we have Germany and Portugal. Looking at these matrices, the most important part are the diagonal values, which as higher as these diagonal values are, the less dynamic a country is. So you can see that Germany, these values are lower than in Portugal, which means that Germany has a more dynamic development. And you can also see on the right side that in the 10-year transition matrices, the diagonal values are way lower than the 1-year transition matrices, which means that over the 10 years, we also have a more dynamic development. Lastly, we have the mobility matrix, which show basically this development of the matrices in one metric, one number. And also here you can see that Germany has one of the highest mobility in the first period, in the first part of our study period, as well as in the second, and it barely decreased as well. While Portugal already had a very low in the first half, which then even increased more in the second part of the study period. Yeah, discussing our results a bit, we found that in general, you can say that the circular bioeconomies of the 10 countries are progressing if you consider all of the indicators. However, this is not a homogeneous development, and some indicators are indeed not progressing but regressing. For example, in Germany, which is the front runner in our analysis, there's still the relative changes between indicators are relatively big, and you also have some indicators that are worsening. Looking at the indicator movement between segments, which we call mobility, we can see that the mobility is way higher in the long term and short term, which is a very not a surprising outcome. And short-term mobility is higher in the second half than in the first half of the study period. And our recommendation for policymakers is that all indicators should be considered to not lose out on any important information. Yeah, our country comparison between countries showed one surprising result that Slovakia, Poland, and Latvia developed quickly in comparison to the rest of the studied countries. This is contrary to a study by Deadamo that's also pretty recently. However, this study looked at the absolute levels of the development, while we look at relative progress. So it could be very well that Slovakia, Poland, and Latvia started on a lower level and only progressing and developing faster, but still have to catch up to the more established countries. And we also find that surprisingly, Finland, Spain, the Netherlands, and Portugal improved the slowest, even though they all have developed and implemented dedicated bioeconomy strategies, which could suggest that only having these strategies is not enough, and you need also more concrete policy actions. Looking at our limitations and future research we want to do, of course, the data availability is, like always, was a problem. And of course, this is also something that we try to address with the Biomonitor project. And we could also assess the initial states of our framework. That would be possible if the indicators had specific targets that would need to be set by policymakers. And then, yeah, we also use to a large degree bioeconomy related indicators, because there is not yet a consistent framework that measures specifically the bioeconomy over a long time period. And in the future, with more indicators, it could be interesting to also group them. And of course, we also want to add more countries to the analysis. And that was my presentation. Thank you.
Thanks a lot, Max, for this insightful presentation on this very important topic. And before we get to questions, I would be interested in knowing where our participants are coming from, that is, which sector they are coming from. So I would like to ask Angelique to pose the poll and invite you to tell us where you work. Okay. So it would help us to understand, of course, also your needs. And now I would like to ask some quick questions to our two presenters so far. We have received some questions. The first one, I think, is for Justus, and it reads like this: in regards to the relation of the bioeconomy and the green economy, what is the role of and how do you define economic growth in your model of bioeconomy?
Right, very important question. No, one quick solution would be wait for the presentation of George Philippidis to provide you some more insights, but that would be a cheap excuse. Now, how we define economic growth, we use first of all the standard economic indicators that are commonly used. For example, how does the gross domestic product change? How does the value added change? Now, we know that if you only use these kind of indicators, that we may not capture all the implications that the bioeconomy may have on development. We have also to take into consideration what might be possible implications on the environment. And if you look back at the indicator list that I did show, we look also into, for example, implications for greenhouse gas emissions that we try to measure. In a sense, we use secondary data on greenhouse gas emissions that have been collected, for example, by the European Environmental Agency, and that are related to specific sectors of the bioeconomy, and then can link this with also economic information, meaning to say what is, for example, the greenhouse gas emission per unit of value added in a specific sector, which provides additional information. What I like to stress here is that there is not just one unique number to measure the development of the bioeconomy. Depending on the question, you may provide or may use another indicator or different indicators. There is also not just one unique methodology how to measure this. It depends again on the specific question being asked. What for us within the project is very important, that we try to be extremely transparent how specific indicators have been developed, so that others have also a better chance to interpret the information that we do provide, and that it may not result in misunderstandings or miscommunications with respect to the results that we are generating. So that for us is very, very important, transparency.
Thanks, Justus, for your answer, and I hope Bernhard will find it satisfactory at least. If not, we are happy to discuss this further later on. And we have another question. I think that one is for Max. The question is there a way to link this analysis, which you just presented, to the EU targets already there for year 2030 or 2050?
Yeah, I'm not sure which targets are meant now. I think at least they don't have. It would not be probably not possible to link it directly with all the indicators.
So
I know
perhaps
that
there are some targets for some of the indicators. So I think that's what is.
Yeah, I think that's the case. So yeah, the problem is that if you want to make it consistent, you would need the targets for all of the indicators. So as we don't have them for all of them, we decided so far not to include some of them.
Okay, and we have another question for you, Max. You mentioned 161 indicators and then 86 for the Biomonitor project. Are they all different? That is there altogether 247 indicators?
They overlap to some degree. As in the Biomonitor project, when we developed this list, we also looked, of course, what's already out there for indicators, and also we looked at this Li et al. Study. So some of them we're also planning to use for our framework, but a lot of them are also different. It really shows that there's a lot of different ways to measure the bioeconomy, and even in the details you can also make a lot of things different just using a different metric, for example.
All right, thanks a lot, Max. I hope this answers the questions of our participants. Again, if not, please let us know. And now I'm very keen on knowing in which sectors our participants work. So Angelique, could you please share the results of the poll? Okay, so looks like the majority come from the public sector. Okay, and the second largest part is from university and education sector, and non-profit, and then industry, private sector. Very good, very good. Thanks a lot for these results. These are very important to us. And now we go to our third presentation, given again by Justus on a very important topic of using the input-output methodology in measuring the bioeconomy. Justus?
Yes, thank you, Dusan. I need to get the right to share my screen. Okay, show my screen. Fantastic. Right, and you should now be able to see my screen. We will later talk about the result for the second polling question. What I want to talk about is the value added of the bioeconomy, and that is already related to the question that we received. How do you measure economic growth? And this is one way of making a contribution to measuring economic growth, what I will present now. What is important to consider when we talk about the bioeconomy and trying to measure its size from different perspectives is to have a definition of the bioeconomy. For many of the aspects that we have an interest in, it makes sense to have what we would call a sectorial approach, meaning to say identifying the sectors and subsectors in our economy that would we consider being part of the bioeconomy. And that is, for example, also something where the European Union has a definition that is basically related to a sectorial view, in the sense that they define the bioeconomy as the agriculture, fishery, forestry sectors that, and the related sectors that convert biological resources into some meaningful products. Now, we did a stakeholder survey at the beginning of the project, asking stakeholders what they would consider as being part of the bioeconomy. And it clearly came out that agriculture, forestry, fishery, to no surprise, has been considered to be full part of the bioeconomy. Also, the food sector, there was unanimously agreement among the stakeholders as being part of the bioeconomy. And then there are a number of other sectors, and we have highlighted them here, that are also considered to be part of the bioeconomy. And we in our project concentrate in particular on those sectors that are often considered to be the bio-based economy. And as I mentioned earlier, the conversion of biological resources into non-food items. As for that specific sector, often information are not so widely available as for other parts of our bioeconomy. And that is where we explicitly focus on getting additional information to be able to define in more detail what the bioeconomy contribution for our economies may mean. And here again, these are the specific sectors where we put a specific focus on. Now, what we did is, first of all, looking at what is the value added that the bioeconomy is producing. And by value added, we mean we look at the output in quantitative terms times the prices. So that are the revenues, and we deduct the inputs. And then we did this for all the sectors that we are considered to be part of the bioeconomy. And again, food and agriculture, forestry and fishery has been considered to be 100% part of the bioeconomy. Now, for the other sectors, we would also love to know to what extent they are using biological resources or resources that are coming from these four main sectors for their production processes and generation of value added. Now, these data are often not directly observable, right? It's not exactly and explicitly calculated for, polled for in the different statistical bureaus of the European Union. So what we did is then, using the value added that is coming from the four main sectors into the other sectors of the economy as an input, and use this share, basically what is the share coming from these four sectors in relation to the other inputs coming from other sectors in the sector of interest, and then calculate the value added using the input shares for the output shares. So this is gives us a rough idea about what the value added in other sectors of our economy will be. We used for this kind of assessment the input-output tables that are provided by the OECD. We derived data starting from the year 2004 until the year 2015. So that is the last year where we have data available. And then normally, depending on how often OECD is updating, we can immediately update also our results. And then did this for all the sectors that are of interest. And the information being generated are now available at the Bioeconomy Knowledge Center, but also at our website. And you can see the link here below on the slide. And you can there identify for each individual member state how the bioeconomy has developed over time with respect to what we would call the upstream sector, so where resources flow from the four main sectors into other sectors, as well as that was a downstream sector, and the upstream sector is basically how inputs flow from other sectors into the main bioeconomy sectors. And these shares have been calculated. And what is interesting, if we look at the contribution of the bioeconomy, what we can observe is that depending on the member states, about 40% to up to a little bit more than 60% is coming from these four main sectors: agriculture, fishery, forestry, and food. About a third is coming from the upstream sector, and about 2/4 are coming from the a little bit more, about 40% is coming from the downstream, is contribution to the downstream sectors. And in some member states, we observe up and downstream sectors have even a larger share than the main sectors. And what is interesting, if you look at these data, and I strongly encourage you to have a look at the website, that we observe somewhat of a U shape in the development of the value added and over time. And this U shape can in particular be explained by the financial crisis. So until the financial crisis, the shares were going down slightly, and then after the financial crisis, that was interesting for us. On average, it of course does not hold for all the member states, but on average, the value added share of the bioeconomy has increased. And for example, if you look at Germany for the chemical industry, there we observe a very strong increase of the bio-based chemical sector after the financial crisis. And the recovery after the financial crisis for that specific sector is larger than the average recovery for the whole economy of Germany after the financial crisis. This is just an observation. We have further interpretations, need further investigation and research to understand what was really driving this increase in that specific sector, but also what is driving the development in the other sectors. For this, additional research will be needed, and that is also something that we do within our Biomonitor project to get a better understanding how the drivers affect the development over time. Now, with this slide here, I like to conclude my presentation. This shows up and downstream sectors and their relative shares and how they have developed over time in relative and in absolute numbers, which gives us a nice summary overview. And we have seen the presentation by Maximilian Kadung. These results are also input into the indicator analysis that Max has presented, but we will also use results of the indicator analysis of Max for linking them with the bioeconomy shares to get a better link between environmental implications and economic implications of the bioeconomy, to get a more comprehensive, holistic overview about what is happening at EU level. With this, I like to finish my presentation. I'm happy to receive questions and hopefully being able to answer them. Thanks very much for your attention.
Thanks, Justus. And indeed, we do have one very interesting question raised by Stefan Becker-Sonnenschein. And it is like this: will environmental discussion shaped with the inputs from the Biomonitor result help to reduce the, quote, sensational doomsday image, end of quote, discussion of our world? What could be the arguments?
Okay, that is a very important question. So to what extent can we have an impact on the current debates that we are observing, in particular what Stefan Becker-Sonnenschein was raising, this doomsday? And I guess he refers to the issue that, the future may look not so promising because of climate change, etc. Now, to what extent we directly will have an impact, that is perhaps even out of our hands. But what we definitely can contribute is to providing additional facts to this debate. And in particular, I think, and that is where we are hopeful that we can show that the use of biological resources is much larger, or that the potential is larger than is currently being exploited within the European Union, and that if we make better use of our biological resources, this will allow to address a number of environmental issues that are now heavily discussed and debated within the European Union. And in particular, I refer here to greenhouse gas emissions. We expect, and we hope that we can show this, that with in the bioeconomy sectors, the greenhouse gas emissions per unit of value added are lower than in other sectors of our economy. Again, will this make a contribution or will this reduce the doomsday perspective in some of these debates? That is for me at this point in time difficult to answer and may depend also on other actors. For example, Stefan Becker Sonnenschein is one of those, how they make use of the results that we are producing.
Yeah, thanks for the answer. We have another question. Will you analyze the strong development of the German bioeconomy post-crisis, and are you hopeful that these lessons could be linked to the post-COVID pandemic situation as well?
We do this if that would now I have to speculate. I think we can perhaps draw some conclusions also, or we can. I'm quite sure that we can draw some lessons from the recovery out of the financial crisis for the recovery of the COVID-19. What these lessons will be at this point in time, I will not be able to tell, because we have first to do our analysis in this regard. But I'm quite sure that we will find some interesting lessons.
Yeah, okay. I have my personal question. I was intrigued by the dashboards which you presented, and I think many of our viewers might actually wonder whether you have to pay for those or are they free to access the analysis.
Okay, no, the dashboard is free of charge. Dusan, very good question. That is free of charge. You can go to our website. There's a link to the dashboard, or you can go to the Bioeconomy Knowledge Center. There's also a link to the dashboard, and there you can play around with the numbers, and you can download them. So everything is freely available.
Okay, thanks. I think that's a very important piece of information for many researchers and users of the information which you produced. Thanks. All right. In the meantime, I would like to invite you to ask further questions in the chat, and of course we can collect them later for the general discussion. For now, I would like to thank Justus for your input, and now I would like to give the floor to George.
Okay, can you see my presentation?
Yes.
Not yet.
We see your screen, George, which is very fantastic.
You see my presentation now? Yes.
Yes.
Okay. All right. Thanks to the organizers. Thanks to Justus and Dusan and Max for their great presentations and for setting all the pressure up on me to go even one better if possible. But my contribution to these presentations really is kind of complementary to what people have been saying up until now, which is a lot of the analysis has been ex post, looking at historical developments and trying to draw lessons from those historical lessons through time. And this part here, which refers to the modelling, is more ex ante, where we try to look into the future to see what's happening in the sort of the medium to long term. So one of the key things that I really would like to explain to you is something relating to the Biomonitor model toolbox, which is really a collection of representative models, simulation modeling capacities, which are capturing different facets or aspects of the bioeconomy. You can see in the bottom right of the slide here, we have the 5 models which form the platform, the principal ones, which are AgMemod, Biomat, FECEN, FEI, GTM, and Magnet. AgMemod is like a partial equilibrium agricultural econometric model, which has been used at member state level for agricultural markets. FECEN is the European Forestry Information Scenario Model, I think it's called, which is very much a biophysical model, which has a great focus on sources of biomass. It uses national inventory data, forestry national inventory data to try and project 50, 60 years into the future, to look at woody biomass availability. It has a complementary model, which is EFI-GTM, which is the European Forestry Institute global trade model, which has an economic component to it, and also has a very good coverage of forestry markets and uses of semi-processed wooden products and resulting trade links as well. And then Biomat, which is a new innovation within Biomonitor, which is a totally new model, which is going to be focused on some of these nascent bioeconomy sectors, in particular the chemical sectors, which is, as I think other people have said before, I think Justus mentioned to this, and obviously Max as well, this sort of data challenge that we face, where in the national accounts, in the NASE definitions, we don't know what the size of these sectors are. To finish off, I'm going to talk about Magnet, which is the model that I'm using within this particular project, and the focus of the rest of this presentation will be on Magnet. But the main takeaway message here is that there is no one-size-fits-all model. We need to have a range of models which we can use to try and give us some sort of coherent picture of the bioeconomy, and we try to link them in a coherent fashion through assumptions, through trying to homogenize, let's say, the drivers, whether it's GDP or population change and so on, in order to give us a sort of a collective picture of what's going on moving towards the future. So Magnet, what kind of questions do we use Magnet for? Now, I quite like this sort of theoretical paradigm here, which is the wedding cake paradigm, which was presented about 4 or 5 years ago, 6 years ago now, by the Stockholm Resilience Centre, where they tried to develop a model which tries to cross-reference the SDGs with this sort of tops-down wedding cake approach, where we have a sort of an economy which functions within or for the needs of society. So these kind of like sort of interconnectivities in both directions, which itself operates within the biosphere. And the biosphere is basically, we're talking about the planetary boundaries, the sort of boundaries that we have in terms of available land and water and the kind of things that Justus was telling us about, which restrict, let's say, or restrain the bioeconomy's ability to meet multiple targets. Now, the reason why I use this paradigm is because it's very comparable to the way the Magnet model works. In other words, we do have restrictions on our total resources. We do have feedback effects. If we try to achieve one particular model aim, obviously we may sacrifice others. So the key point here is that there isn't a free lunch. Okay, you don't get your dinner ticket and it's all free. No, you have to think about how different policies will synergize or possibly trade off amongst one another. And that's the kind of thing that we try to do with Magnet. That's pretty much the essence of the model. So here we have a very stylized representation of the model. I'm not going to get into detail. Basically, it's based on behavioral equations which dictate how people demand and supply resources. It has a series of market clearing equations, so markets always clear, supply and demand is always equal to one another, so it's an equilibrium model like the other simulation models I discussed before. And it has a series of accounting equations to make sure that the balance of payments is closed and all the circular flow of economic activity is completely closed and consistent with the underlying data that is used for this particular model. So it's a global model which connects a series of regions together, and you can look at global questions along the lines what we've already shown with the wedding cake paradigm. Its bioeconomy coverage is pretty good for models of this size, of this type. On the right-hand side, I'll just quickly explain that we see the numbers of sectors which are bioeconomy related within Magnet. So agriculture, forestry, fishing has now 5 sectors compared to most models of this size, which is usually 1. Has coverage of food and beverages, bio-based textiles, and so on and so forth. At the bottom, you see there's also coverage of energy, nascent material sectors, and also bioelectricity. There are indeed further advancements which have been added since then, including municipal waste and the sort of circularity component to the bioeconomy as well, which I have not shown here, but this is kind of more recent developments. So how do I want to show you what this model can do? Well, I use the GECO, which is the Global Energy and Climate Outlook, in order to motivate a study which I did actually when I was at JRC, which was looking at 3 specific pathways. And the real ethos of this study was that it provides assumptions going to 2050 of energy market developments and climate developments. And as Justus has already said before, you can't look at a study, an ex-ante study of the bioeconomy without taking into account what's going on with climate change and what's happening with the energy markets and how that impacts on potential usage of biomass through time. So the study itself is very useful. We're going to be using it in Biomonitor. The timing of this presentation is a little early. We don't actually have any results for the current Biomonitor modeling capacity that's coming soon, but these results that we have here do use the same source, and they are kind of based on these sort of 3 main levers, which is the idea of having energy efficiency through time, based on these 3 narratives, energy carriers shifting towards electrical use of the electrical grid, let's say, so towards electrification, and a sort of thorough decarbonisation of the energy system. And the 3 narratives, the reference one is basically business as usual. We have a 2 degree and a 1.5 degree, so there's an increasing level of ambition of those 3 sort of main levers. And I'd like to just try to present to you some of the results that we've done implementing some of these assumptions into the magnet model through the theoretical paradigm, which I've shown you before, which is the 3 layers, the sort of the biosphere, the society, and the economic. So starting with the biosphere, what do? We impose into the model, for example, assumptions regarding energy changes at global level and carbon permit changes as well. And you can see here that the blue line is the 2015 benchmark, which in the orange line increases to the 2050 level. So you can see there's a shifting upwards of the curve in most of the regions. Emissions are increasing at global level from about 44 million tons to about 60, I think it is. But then you look at the other scenarios in terms of what does the model tell us about how much emissions will reduce when we impose these energy assumptions. The emissions in the 2 degree scenario reduce to only about 22 million tons of CO2 equivalent, and that falls to about 11 million under the 1.5. So this model can give us some indication about how actions in energy markets and climate policies can impact on emissions. On top of that, another example I choose is the SDG 15, which is life on land, where we look at agricultural land requirements. So on the left-hand side, you can see millions of hectares. It's like a biophysical measure. And on the right-hand side, you can see percentage change. And what we're saying here is that let's say take the example of sub-Saharan Africa, the black dot shows us that agricultural land usage in the reference scenario over 35 years is increasing by about 26%, which is equivalent to, if we look at the yellow line here, which is equivalent to about 280 million hectares of agricultural land. Now, the model can tell us this, and other models can tell you that as well, in terms of what would be the impact of a series of drivers. One of the interesting things about magnet, though, is that you can actually decompose these drivers to look at the relative magnitudes or the part worths of each of these effects. So, for example, the blue one, the blue bar in sub-Saharan Africa, here, shows us the impact of increasing incomes per capita on agricultural land demand, which is around, say, 375 million hectares in Africa. Population change also has an increasing impact, as you would expect, but you get to see the relative magnitudes. These are offset by the green driver here. I've simplified it a little bit, which is land productivity. So obviously land productivity effects is going to play a very important role in Africa to offset these sort of increasing income per capita, increasing demand for food, these Malthusian concerns about population increases we need to have some offsetting effects, and we expect that land productivity is going to play a role in that. Looking at society, I've chosen calorie intake. So calorie intake is measured based on FAO balance sheets, and we try to mesh those data with the demand patterns within the magnet model to try and develop some estimates of average per capita calorie intake per day. And we can see for each of the regions, a selection of regions here for 2015 and for 2050 in the reference scenario, so the business as usual scenario. And as we can obviously see, there are increases in calorie intake, obviously a lot stronger in the developing countries in sub-Saharan Africa and Latin America, and in the world as a whole, where calorie intake increases by about 20%. In sub-Saharan Africa, we see increases of calorie intake per capita per day of around 800 kilocalories per person. So I mean, it's quite a big jump. And if you move even further, we can see that this 800 kilocalorie increase, which is indicated by this yellow line in the reference scenario over the 35-year time period, which is equivalent to 36% increase in kilocalorie increases per person per capita, we can also break that down into its relative drivers. So on the one hand, you can see that increasing per capita incomes is translated into increasing food demand, which increases into increasing calorie intake. On the other hand, again, we see that population, if we look at growing population in the absence of all the effects of the other drivers, it really is driving down per capita increase in Africa significantly. So clearly there's again, we revert back to this issue about the Malthusian problems of population rises in certain regions of the world. This is a particular pressure point. You don't see that in the EU or USA, Canada, because population growth is not as great. And also demand patterns in terms of increasing demand for calories is nowhere near as great as it is in increasing, you know, in quickly increasing economies of Africa and Latin America. Comparing with this reference scenario and using the same indicator of average calorie consumption, we can also see further stories with the model. So for example, if I just jump quickly to the right-hand side, because we're probably running out of time, on the right-hand side, you can see that in India, for example, there's a big blue bar which shows a negative impact on calories per capita per day. That is because of this trade-off effect between climate change policies and the cost that it has on macroeconomic growth. It's not a free lunch. So per capita incomes are expected to fall if we are to meet the 1.5 degree requirement. And as a result of that, it has an impact on calorie intake per year of about just over 200 calories per capita per day per person. The red bar with the emissions shows the isolated impact of the carbon price and how that impacts on food prices. And food prices increasing obviously means that we can demand less food. So again, we have these sort of conflicting aims where on the one hand, we're increasing our potential to realize environmental indicators, but on the other hand, market indicators such as, or social indicators such as calorie intake are being sacrificed. So these trade-offs which occur. Economy, regional real per capita income I've chosen for this reference period between 2015 to 2050. So given the assumptions in this GECO study in the reference period regarding real GDP growth and population growth, what happens to real per capita incomes in 2011 prices? And we can see that the USA and the EU obviously are growing quickly. There is a larger proportional growth in the regions such as Sub-Saharan Africa and Latin America, where we can see sort of a threefold growth or an even sort of a 2.5-fold growth in Latin America. So in proportional terms, these countries, their income per capita is growing faster. But when you examine the issue of income convergence, you can see that the EU, which is about I don't know, about 3.1, I think it is 3.1 times the world average in 2015, it drops to about 2.1 times the world average in 2050. So there is convergence there, it's converging towards the world average. Sub-Saharan Africa is about 20% of the world average, it increases to about 30%. There is convergence, but it's extremely slow. So are we converging fast enough? Given the evidence here, it doesn't seem to be the case. If you look at the other scenarios, which I've not shown you, the 2 degree and the 1.5 degree scenario, the story is particularly similar. We don't see any particular acceleration in income convergence either through time, which is obviously a worrying trend, and we need to think about implications of that are for economic and human development. Finally, I've got this particular slide, which looks at a very stylized what-if scenario. So what we've done here, we said, okay, in the 1.5 degree scenario, let's assume that there's no more support for first generation biofuels. There's no more public support, and we just let the model determine what will happen to biofuel production. So as you can see, we've got a very, very small part here. This part of the circle here, this relates to first generation biofuels. The rest of it has to be made up by advanced generation biofuels. So there's a GECO target, which we have to meet, of X million tons of oil equivalent for biofuel usage in transportation. The difference between what the model tells us that biofuels from first generation and the total from GECO must be made up by advanced generation biofuels. And the model will tell us what the regional split of each and every one of the regions are. Now, the two main points I want to make here are, number one, Brazil seems to overtake the USA and Canada in the sort of the first generation biofuels market. So it's about 50% now, the biofuels market for the standard biofuels, biogasoline, biodiesel. But the other point is that how much tech change do we need in order to make sure that advanced generation biofuels get us to where GECO wants us to be, or the expectations from GECO? And the result seems to be that we would need something along the lines of a 10-fold increase in technology per annum, compounded over 30 years, in order to achieve this. So is that realistic? Takes me to my next slide. Take-home messages. One, there's evidence of population weight on planetary boundaries. We've seen this in terms of the land use results. Malthusian pressure seems to be growing. So obviously there's some issue relating to a pressure point in Africa, which we've identified, which is looking at policies to mitigate this impact, whether it's relating to family planning programs or other types of burden sharing. There's a high reliance on biotechnological land productivity improvements. Magnet uses bottoms-up model inputs from the image model, which is a crop-based model, in order to give it its predictions of how crop yields can change over time. But whether or not these are credible or not is open to debate. Climate control gives us evidence of synergies and trade-offs. On the one hand, there are synergies. We have lower temperatures, reduced land use pressures. Okay, that's wonderful. But food affordability is something that we have to worry about, and food calorie and food security shortages is something which is particularly compromised. Again, the sub-Saharan African case is a case in point. And again, it reinforces this message of burden sharing that we need to look at. Income convergence is very slow, and other pathways don't seem to make a great deal of difference. And the sustainable pathways, when we look at a more sustainable pathway using sustainable advanced biofuel technologies which use non-food lignocellulosic crop feedstocks, the question is the technology there to support this switch? It works very well in terms of not increasing food prices, and food security obviously is not affected in a negative way. In fact, it's obviously very beneficial for those types of indicators. But the technology increase is rather significant, which suggests that there may be a role for conventional biofuels moving into the future. Thank you very much.
Thanks, George, for your insights. And let's get right to the questions. The first one is, boundaries like square meters of agricultural land depend on the production technology. Now, how are future developments of acreage measurable? If fermented protein production is 400 times more effective in production than cattle breeding, for example, or will it only be a look-back perspective?
Okay, so I mean, when we're looking at new sort of disruptive technologies in magnet, we don't have coverage of new methods, let's say, of agricultural production. And we have to try to approximate productivity improvements through simple input-output expectations. As economists, I put my hand up and say that, you know, our understanding of technological change is limited, because obviously you're having to look into the crystal ball and you have to look into the future to see to what extent expected technology change is going to make our lives better. The more, obviously, the better. But in terms of these new sort of disruptive technologies, this is one of the things that we're really trying to look at in the Biomonitor project, in the toolbox, where we try to improve the existing models by introducing new value chains. And one of the models that I discussed at the very beginning, which is the biomat model, is looking at new value chains in biochemicals, for example, and how we can incorporate those and predictions of how evolutionary developments in those types of technologies can benefit the bioeconomy. Now, in Magnet, we're also looking at biochemicals, but new developments in livestock sectors, unfortunately, we're a bit lacking. We just have feed efficiencies, and these feed efficiencies, they come from bottoms-up models, which are inputted exogenously.
Okay, thanks. Another question. There will be some data gaps and uncertainties in the model input data. And how certain are the conclusions from the Magnet model? Do you run sensitivity analysis or uncertainty analyses?
Yeah, so these models are deterministic. They're not stochastic. So obviously, you know, right off the bat, as I said at the beginning, we have equilibrium assumptions, and we assume that market's clear and everything is, you know, deterministically determined. Sensitivity analysis, you look at the key parameters, and this tends to be the response parameters with respect to prices. We do run sensitivity analysis to some extent when we're looking at key policies. We try to develop, I mean, baselining is a big role of simulation modeling, and you try to generate a baseline which is as credible as possible, and it goes through many filters with many policymakers to see whether or not it meets reasonable expectations of how, you know, the planetary evolution and human development is expected to go. But it's a good question. I mean, we do try to look at key parameters. It may well be, for example, the availability of land assumptions, and we try to play with different supply curves, perhaps for land, looking at different elasticities of land supply to see to what impact it affects prices, and therefore availability of land and the resulting biomass. Or we may also look at other elasticities of demand in terms of the demands for specific bio-based products. So you would have to say, yes, you need to take the results with a certain degree of caution. The results as they are based on best available estimates of elasticities and supply. And of course, it's very prudent to do a sensitivity analysis where possible. So yeah, absolutely agree with you.
Thanks. Somewhere earlier in your presentation, you mentioned that, of course, Magnet is not the only model we are going to use in our modeling palette of models in the Biomonitor project. And so I think there will be a time when we have to compare the result of the models, you know. And so how do you, and you were also talking about baselines. Could you maybe tell us a little bit more about how you want to make it all comparable? We know that the models, each model is specific in some sense, but there should be some something in common,
yeah.
right?
Yeah, thanks, Dusan. That's a good point. I didn't make that point in the presentation. So within the Biomonitor model toolbox, one of the things that we're trying to do, as I mentioned at the very beginning, there's no one-size-fits-all model. So one of the things that we're trying to do is we're trying to harmonize the assumptions of these models. Now, the models obviously have a very different levels of granularity. Some are very specific to the forestry sector and have extremely high detail of forestry. Another one is extremely concentrated on agricultural developments at a very high level of granularity as well. Another model, which is I've been talking about, which is Magnet, is a big picture model. So from a data structure point of view, they have differences. In terms of the driving mechanisms, they also have differences. The forestry models are, the Ethicen model, for example, is a biophysical model. It has a lot more detail than Magnet will ever dream to have regarding biomass availability. So we have to overcome these problems, and that's one of the things that we're trying to do in work package 4, which is to develop a series of coherent links between these models in order to develop a sort of a consistent and coherent package for policymakers. How do we do that? Well, we try to use a consistent source to start with, which is the Gecko source. I talked about an older version of Gecko. We're actually using the 2021 now version of Gecko to look at expected trends in GDP and population, which are inputted into all of the models in the macroeconomic assumptions that are consistent with one another. But on top of that, we try to develop this idea of linkages as well. So For example, Magnet is the only model which will implement energy market developments. But obviously, there may be some results that come out of Magnet, such as world price developments for fossil fuels or downstream demand for wood, textile, construction products, or whatever, which can be fed into, for example, the FEGTM model. Or there could be some synergies from AgMemod in terms of specific agricultural market developments where it is particularly strong, which could be used to condition the baseline in the Magnet model. So there is a series of linkages that have to be discussed and also have to be implemented. A final point I would also make is that Biomat is a derivative of AgMemod. So those two models are going to be very much linked to one another. I mean, the structure of the equations of the models themselves is extremely similar. So one hopes that there will be some very, very solid linkages between what's going on in the chemical markets in Biomat and the agricultural markets in AgMemod.
Okay, thanks, George. Yeah, before we proceed, I would like to ask you to stop sharing your screen so then we can. Yeah, so this brings us to the second part of our webinar today. That is the general discussion. But before we go there, I would like to ask all the participants to answer a simple question in the chat. How can Biomonitor best contribute to the bioeconomy as part of the Green Deal? Okay, so if there will be no poll on this. This is kind of an open question, but we are curious about your opinions. Again, how can Biomonitor best contribute to the bioeconomy as part of the Green Deal? And of course, there's also room for further questions of yours. We still have 10 minutes or so. So if there are any questions from the audience. I cannot see anything at the moment. So perhaps before people type their suggestions, do you presenters, do you have any ideas on this?
Actually, I would like to ask something to George. So with this Magnet model you use, to which degree also do you consider changing consumer preferences? Did you, for example, look at a large shift of people maybe eating less meat or eating no more meat, which could have a large impact then again on the land use, the amount of land that is used?
Okay, yeah, so that good question. It ties in very much with the bigger question, which is how can the bioeconomy help to respond to these global challenges? The answer is yes, not in that particular study that I showed you, but there is work at the moment which is being led by colleagues in JRC, Kirsten Urban and Robert Mbarek, and myself. We're working on how to model changes in food preferences. In two senses. On the one hand, you've got the Lancet diet and how changes to a sort of a more vegetable, horticultural sort of based diet and away from meats is benefiting not only land use as we've shown it here in this presentation, but also trying to look at this idea of virtual trade and footprints to see to what extent virtual trade in land and greenhouse gases and also energy, in fact, is impacted. And preliminary results suggest that, of course, yes. I mean, you know, it's a bit strange actually, because the EU looked a lot worse before when the UK was part of the EU. As a British person, that stresses me quite a lot. Now the UK has left because the UK is a big meat eater, and they were eating a lot of meat from Oceania, which has a huge land footprint. Then obviously taking the UK out of the EU bloc makes the EU look a lot better. But it is a good example of how if the EU was to reduce, for example, its meat consumption from a particularly concentrated meat producer such as Oceania, then obviously its land footprint would be considerably reduced. These leakage effects would be reduced considerably. So it's not something which is in this study, but it is something that we're going to look at in Biomonitor, and I would guess in the scenarios when we look further on.
And let me add something to this example of the UK. I find striking in the sense when we look at policy implications, etc. Right? Where do you draw your boundaries? And you can manipulate your results by just excluding a few countries, or, forcing countries to leave, and then the EU looks much better. But basically for the world, nothing has been improved, right? The UK are still there. They still contribute with all their activities to the allocation of resources. And I think that is something where we have to be very, very careful and have always to stress, right, that we are living in an interdependent world. And it's not just only enough to look at what is happening in the European Union. We have to take into consideration what is happening in the rest of the world. And magnet or these GTAP models are one way of taking this global perspective into account. And that is very, very important.
Yeah, in the meantime, we have received several suggestions on or answers, possible answers to my question. So the first one is by Jurian Spekreise, and the suggestion is like, Biomonitor can best contribute by supplying open, scientifically sound data and models to use as a foundation for building arguments and scenarios. So I think that's what we actually, this is very much in line with what we try to do. So I'm happy to see, right, that people also think similarly. Then Bernhard Kastner, Biomonitor should remind that standard economic indicators are only few among many development indicators. Since those standard economic indicators have until today failed to ensure sustainable development, Biomonitor must insist on further weighting of ecological and social indicators. This way, the resources mobilized by the Green Deal are ensured to be used sustainably.
I think one way we have seen by the study of Max, right, how you can include these indicators into an assessment. So we take care of this. If I think it's perhaps asking too much from our project, that we are able then to change the overall perception in the European Union or the policy making with our project. I think there are many other issues that also are at place and influence policy decision making. And I think we can make these contributions with the information, etc., to the policy making. But how these information then later be interpreted within the policy settings, I think there we as a project are a little bit limited, right? So we have to be careful, not overstress also what can be done by a specific project.
Yeah. And then Stefan Becker-Sonnenschein finds my question very tricky. He says, a Biomonitor can contribute to the Green Deal if Green Deal defined targets and indicators that can be tracked and measured by Biomonitor. So the goals of the Green Deal need to be as clearly as possible defined.
That is what we all love, right? But that is not what policymakers want, right? They not want necessarily to have very clear measurable policy targets being set, because this allows to basically prove whether or not the policies did make sense, or to check on their policy. And that, for understandable, is not always necessarily their objective. But maybe George or Max also have a view on that.
Yeah, I mean, it's a bit of a chicken and egg, really, isn't it? I completely agree, actually, with this point. Is the hot potato with the policymakers, or should it be, you know, with us, the academics, let's say, the researchers, in terms of the sort of the input that we should give to science? Obviously, I think, you know, if I were to sit on the fence, I would say 50-50. Obviously, you know, we have to play a role. We can't just be passive actors and expect policymakers to come up with everything. That's not fair. I think we are making some attempts to develop some social indicators. I know that JRC, in terms of the inputs they have into the magnet model, and perhaps into the other models as well, in the Biomonitor model toolbox, are trying to develop a series of indicators which are consistent with Eurostat statistics, which do take into account also social indicators, which may be related to things relating to obesity, you know, not just market indicators, but things related to obesity, or it may be relating to, you know, education levels, life expectancy, and things like that, which can be included in simulation models with some degree of econometrics and a bit of a leap of faith. So we do have a possibility to try to expand our horizons a little bit, but obviously I think it's pretty normal that we take our lead from the policymakers, and we just try to bounce back, let's say, as best as we can to provide evidence-based scientific policy advice.
Yeah, and I think this very last comment we received is very much in line with what Max was also mentioning in his presentation, that unfortunately there is no, unfortunately we don't have a situation where each indicator would have its specific target, right? So that's why he couldn't perform his analysis to its full potential. Okay, there's still 2 minutes till the end, so if there are any questions, we would be happy to hear from you. It looks like there are no new questions. So I think we have successfully come to the end of today's webinar. I would like to thank our 3 presenters for their wonderful talks and insights, and I would also like to thank the audience for providing very curious and inspiring questions, and also helping us to understand how Biomonitor can best contribute to the bioeconomy as part of the Green Deal. Please stay with the Biomonitor project. You can follow our what we do in our website, biomonitor.eu. We frequently post the policy briefs, which I think are very useful and easy reading, right, for a general public. So this can be also very informative. And of course, if you have more specific questions to any of the presentations which you heard today, please send a message and email to the presenters direct, and I'm pretty sure they would be happy to discuss your questions further. So again, thank you very much, and it's been a pleasure to moderate this session today.
Yes.
Thank you. Bye.
Thank you.
Thank you, Dusan, and thank you to Icons for organizing this. Bye-bye.